on artificial intelligence and the FAIR principles. Today we have a panel of 4 people, and 2 of us will alternate a bit between being a host and also an inviting expert. So today we have Karel Schervat, we have Johannes Athanasius and Len van Wassenaar in the panel, including myself. And we propose to first have a round of introductions of the 4 of us, where we give an introduction to the topic, and later on we will discuss a bit more other topics other than from the area where we work on. So if I may start by myself, my name is Eric Vrienga. I work for Food and Agriculture Organization in the Office of Innovation. And currently I work a lot on data topics, including the work on blockchain, but also the work on artificial intelligence and the ethics of artificial intelligence, to whom we contribute through the United Nations Chief Executive Board. So also there on that level, the UN is trying to relate to the discussion actively on the ethics of artificial intelligence. So I stop here. I would like to hand over to Johannes Athanasius, from whom will co-host with me today this meeting. Over to you, Johannes.
Thank you very much. Good afternoon, everyone, and welcome in this session. My name is Yannis Athanasiadis. I'm a personal professor of artificial intelligence with Wageningen University in the Netherlands. My research is on the interface between artificial intelligence and agricultural and environmental applications, and my expertise is with machine learning, big data, and knowledge engineering. And I'm very happy to that we prepared this session together with Eric, Lan, and Karel, because I really believe that agriculture brings new elements into AI and AI research, but also it can benefit a lot by AI research. But how do we do that in an inclusive and fair way is not always very clear. So I would be very excited to have this discussion with the rest of the panelists. Welcome, and Lan, would you introduce yourself next?
Thank you very much, Johannes. My name is Len van Wassenaar. I am a senior scientist at Wageningen Economic Research, which is part of Wageningen University and Research. So I'm actually a colleague of Johannes. My work concerns also a lot about data, but I look at data and data economy from the perspective indeed of economic applications, and also ethical considerations are part of it. So the topics I wish to discuss today with you are, for example, other economic principles in addition to FAIR, and how do FAIR principles fare in comparison to other principles. So I hope I look forward to a lively discussion with you. Thank you.
Thank you, Johannes and Len. And then I would like to give the floor to Karel Schervat. Please introduce yourself.
Hello, my name is Karel Schervat. I'm working as project manager for Plan for All and Wireless Info. For me, this topic is very interesting because I was one from the first in our country. I started with artificial intelligence in '86. And from 90s, I am working mainly for agriculture, data, big data, and other topics. So this is very interesting for me. Currently, I am involved in GEO. I am part of program board of GEO, and also I am chairing agriculture working group in OGC. So all these topics of today's discussion are my big interest.
Thank you so much, Karel. To all the audience, we in the last 15 minutes of today's hour, we will have 15 minutes of Q&A. So you can already put in your Q&A here, and while we're going, we also keep an eye on the Q&A, so we may address the questions already. But at the last 15 minutes, we would like also to give you the floor, and then please take the camera and the audio so we can have a lively discussion. So I would like to start off with the topic of FAIR in relation to ethics and AI capacity building. So for instance, from my own perspective, we try to understand what does it mean if we apply, how can we build up capacity within FAO, and we try to integrate AI techniques in our products. And for instance, one example is the hand-in-hand platform with a lot of geospatial data, and already there a lot of AI techniques are used. And we also do analyze Twitter streams within the data lab of FAO. But this is all about in the realm of AI capacity building, making sure that we use the power of AI in our products and works. But the discussion on AI ethics is sometimes a bit blurred because, and I believe this is a general problem to understand what are the ethical aspects of all the process which we have at hand when we apply AI, and how could we use then the FAIR principles to manage that better. And somehow I believe we really need to go towards an AI ethics governance framework, and using maybe even the FAIR principles, we could operationalize the notion of AI ethical principles better through a framework like FAIR. So I would actually go around between you speakers. Maybe we can start with Karel. How do you feel about the expression of AI capacity building and AI ethics in your work, and how do you relate to that? You're muted, Karel.
Sorry, I think that big issue and the big problem is in agriculture with heterogeneity of the data, and with the fact that we are working with a huge number of small units. Yes, every farm is a small unit, and a lot of data is stored in different things. Some data are stored on the farmers, some data are, for example, on the machinery producers, some data are on the consultants. So we have a number of, could be technological problem and standardization problem, but of course we have also the problem with the data ownership and data access, yes, because the farmers' data could be very sensitive, and it is necessary to find such model that data will be used in the advance of farming, because without this they will not agree to use their data, and without direct data from the farm probably we will have problem to use any artificial intelligence to solving the things on the farm, and farmers has to be trusted. Yes, this is very important, and I think that we will discuss this issue more later.
Thank you, Karel. Len, would you also like to give your opinion and insights on this topic?
Yeah, sure. I think AI capacity building and capacity development should definitely go hand in hand with AI ethics, although they may not concern the same users or same stakeholders at the same time. In our own work, we do realize that there's a great need, not only just among smallholder farmers, but also among researchers, people working with AI, for better capacity and understanding not just data science technology, but also the applicability of AI algorithms and what the implications are. So I think those are the typical topics related to AI capacity building. At the same time, I think the ethical considerations are just as important. For example, when we build AI algorithms, there are always some criteria or objectives being chosen, and I think there it should be held to ethical considerations to make sure that it's inclusive, it's not benefiting a smaller group than the greater public. So I think the two aspects should be considered at the same time, and I think it's good to look at them maybe in a specific application in different use cases as well.
Thank you. Over to you, Johannes.
Yeah, I think That's a very relevant point between capacity building and AI ethics, because from a capacity building point of view, there are different levels of this capacity building. So one, and to me, it's also somehow related to the notion of trust. So it's not only about developing AI solutions, but it's also about using them and trusting them. And then the ethical considerations are there, but not necessarily taking over everything. I mean, you could argue about, is AI ethical or not? I mean, a simple answer is yes, unless you do something unethical, right? So it's more or less like a knife. We use a knife because we need to cut our bread or to prepare our food. Doesn't mean that we will use it for harm, but then we know and we're very comfortable in managing the risks of having a knife at home. And we wouldn't give it to babies, but we will safely store it. So in that sense, capacity building is also essential for understanding both the risks of applying and using AI, but also realizing the ethical considerations that come with AI deployment. So these two, in my opinion, come hand in hand, and the co-development, the inclusion of stakeholders into building AI solutions is essential. Yeah, back to you, Eric.
Thank you, Johannes. Yeah, before, because I would like you to introduce the next topic, Johannes, but what I would like to mention as well is that there's a kind of contradictio in terminus when it comes to the word fair, because when you read about bias in machine learning and in artificial intelligence, they also use the terms bias and fair. And it's funny that there's a coincidence with the FAIR principles. So the question is, how do we use the FAIR principles to express a concept like AI ethics and bias and fairness into the FAIR principles? Maybe over to you, Johannes. Could maybe introduce the next topic if you have it at hand. Otherwise, I can go with my topic.
Sure. Yeah, I think the next topic we would like to bring up is how suitable are FAIR data principles for sharing AI models. So on the one hand, we do have FAIR principles who are mostly or originally made for sharing data. Now we are getting into an era that AI models are becoming more and more important. And there is a lot of initiatives around the world from companies, from associations, from researchers on sharing AI models and how to do that in a way that they follow similar principles of being findable, reusable, accessible, and interoperable. The real challenge is, so there is a momentum in applying FAIR principles to AI codes and AI models. The real challenge is, how can we contribute to this momentum? Is FAIR principles enough? Do we need something more? And yeah, let's have a round with this, and maybe I will come back with an additional question. So, Karel, would you like to go first?
Okay, I think that in some way we have divided between the software and models, yes, because as you know, now the most of software for calculating AI are open sources, yes. There is a huge number of open sources, and almost everybody has the chance to discover some system, take some system, install some system and run, yes. Other things is to go with concrete models, yes, and I think that this is much more complicated, because sometimes these models are the part of some company businesses or other. Usually you can read a number of papers about the existing models and preparing, but till now it is not very often that these models are offered to us publicly. There is also one thing which I see. I participate on number of the projects which solve some problems, but the question is who will use this model, because very often this model are not used by real end user, by farmer, because farmers has no skills. So I saw in many cases that they are developed marketplaces for sharing of this model, but till now usage is not so good as is usually expected. Yes, this is again done by the complexity and situation of the agriculture services.
Thank you, Karel. Lan.
Yes, thank you. I am very much in favor of the FAIR principle when it comes to data sharing, especially about open data. But as economists, I do see some potential danger of applying it similarly to AI models. Because I think models have always some hidden value judgments, which are not universally applicable or acceptable to all people. And I believe you cannot simply apply a model that is developed within a specific context to another context without taking into account many context-specific factors. So that's just one example which I see that you cannot simply apply a FAIR principle to for data sharing to the sharing of AI models. At the same time, I also see that FAIR principles are very much technology driven from a technical point of view to make sharing data easy, facilitate sharing of data. But there are considerations such as privacy or other considerations that may require other principles other than findable, accessible, interoperable, and reuse. For example, the inclusiveness and privacy considerations. So I think we should look also into existing other governance principles for sharing models or AI algorithms than FAIR principles.
Yeah, thanks.
Yes.
Eric, maybe your view on this.
Yes, well, regarding the FAIR and AI models, as a matter of fact, I believe today I'm not aware of a real interoperability for AI models, and maybe I missed something, but there is interoperability, but within certain realms. So if you go to the Python community, there is a kind of working practice about how they will run their models, and they use all sorts of Python notebooks, and you can run them in the cloud. So it's more that the practice is interoperable than the model itself. And for instance, if you look at machine learning packages like RapidMiner or BigML, they have their own model language, but that language is not standardized. So again, they are interoperable within their own community, but not further than that. And the same applies, for instance, to the remote sensing engine from Google, where they use Google Earth Engine. The whole API is published, everything is standard. But that standard has not been taken to the Open Geospatial Consortium to put forward as a standard. So I cannot run my Google model and bring it to the Amazon cloud and run it there. We are very far from there, actually. So I believe there's a lot of work to be done to make all these models interoperable. And I believe it's important because, for instance, the question that Len was raising, like a certain model is not portable to another context. That means that you can actually bring it to another context. And before we can do that, then we still need to standardize a lot. And then we need to think through that for instance, on the concern that Lan was raising, how do you make sure that, for instance, through the FAIR principles, you raise certain concerns like Lan raised, that you cannot bring a model from, so to say, from Africa to Asia or wherever, from one industry to another industry. So yeah, I think that's my take, that that I would be in favor of making all these models findable, accessible, interoperable, and reusable through FAIR principles, because that kind of infrastructures, or is a precondition to have a proper discussion on this, on what is the contextual problems and ethical problems of all these models. Over to you, Johannes.
Yeah, thanks to all the panelists for your reflections. I also see a couple of very interesting comments in the chat. So one is by Daniel Martini about the duality between code and data, and what is where you draw the line between model and data. Maybe it's somehow blurry. I totally agree with that. That's from a service point of view, models are just data producers in a way, so there are a lot of similarities there. And also Jennifer is mentioning that we need to modify FAIR so that data for FAIR and for codes to include also modeling assumptions and choices, which I think it was also mentioned by the panelists. And Gideon is very much appreciating Lan's points of view, and raises the point that having rich metadata describing the potential biases could help. But yeah, to be also very open about this, I think it's also kind of challenging and a moving target, that as we are using or reusing models, we may start realizing more biases or limitations that we need to make explicit. So in a way, it's not a static annotation or a static declaration about the model, what are the biases and what are the limitations, but maybe that's something that you can, by using it further, you can disclose more, or you realize more limitations. And that brings me to another aspect related to FAIR data principles and how good are they for sharing AI models, and to ask for another round of comments about how do we share, open and validate AI models. Typically AI models are treated as black boxes. How easy is it from your own experience to actually validate and reuse other people's models? So Lan, shall we start from you? How do you have any experience to share? What is your opinion about this?
Well, in general, I think it's many models are well documented, so it's quite easy to reuse. However, you do need to use your own domain knowledge to interpret the results and to derive further implications. So I think that part you cannot simply reuse and pick up the results as it is. And that being said, I think metadata, but also description of the scope of application of the models, those are very important aspects for making the models reusable. And that's I think Jennifer also there was another remark that the metadata should also be regularly updated with versions, and that's also important aspect. And I think there's still a lot of work to be done in our fields, because we have simply many models that are not well documented, not validated yet. And I see that's a major research agenda item that we could all contribute to for collective work, collective development of AI. Thank you.
Yeah, thank you, Lan. Karel.
I think that The question is if we want to reuse some model in could be some laboratory test, or if we would like to go to some broader usage. Yes, because if we would like to go for some laboratory test, probably I am able to take data, transform data into the form which will be possible to combine this with AI model and to do this. But if we would like to go to something broader usage of this model, we will become to other problem, and this is not sometimes fair principles for sharing of the data. And if we have no standardized access to the data and other, it is very difficult to use some model in broader, because then could be some cost for transferring of the data into the format which is good for concrete model, very timeful, and you can spend a lot of time. So this is, I think, necessary to discuss not only the FAIR principles for model, but we need to go again back to the data, because without this it will be very difficult to reuse the different models in larger scale.
Oh, very relevant aspect. Huh? Eric, any last comment from you, and then the floor is yours to move to the next topic.
Yeah, regarding the models, I often see kind of parallel with data governance and data management. And in practical terms, I see data governance as kind of the handbook of how you can do data management. And within the European Union, there is the GDPR, and probably that was a milestone data governance framework. And from there, all the institutes are now really doing data management. And why? Because they have to by law within the EU. And it actually took a long way before we got there, but now you see that a lot of organizations, they talk about, and actually I spoke lately with Lan about this, about having a chief data officer. And this whole notion of data governance and data management is becoming kind of more normal. People know about it, there's more awareness about it. But regarding AI, I do believe we still have a long way to go. It would be hard to imagine, for instance, that the EU would issue next year the GDPR for AI. But somehow I believe we need to go there. So that would be my comment, that it is the time to start thinking of AI governance and management. Then if we start linking making the link to the agricultural space, what are the specific issues that we would need to think of when we think about agriculture, AI, and FAIR? Does FAIR work already well within the domain of agriculture, and can we then integrate the notion of AI there as well? Maybe I can hand it over to you, Karel, this question, and then we follow with the others. Over to you, Karel.
All right. I think that this is really difficult and long problem, and I have to say that I'm working about the FAIR principle for agriculture data for a long time. But okay, we have here people from all world, yes. But if we only will go to the Europe, for example, we have this land parcel information system in every country, which is in some way managing the data about the farms in different countries. We have more formats of this land parcel information system in Europe on the level of the countries than we have the countries. Yes. So, and if we will go to other things, yes, machinery producer, they are agreed to use, for example, to access all the data Isobus. But if you will look on the implementation of Isobus for every producer, again, they will be the problem to read this directly. If we will speak about IoT data, sensors data, yes, then it's situation much worse, because we have some OGC standard, or could be future internet standard and many other standards. So in reality, we have no standard if we have so many standards. But every big producer or of sensor or every big provider of the clouds, they use its own standard for the data. So again, there is the problem. Yes, on the level of the farm, there is number of systems, and very often farmer is needed to work with the different systems which use the different data. And I think that here this topic is discussed, yes, on many levels, but till now we don't have some good solutions. They are discussed some model, yes, they are discussed some model for RDF data, which could be good, but generally there is a lot of work, and in some way it's necessary to put all organizations who are in some way dealing with this problem together. Yes, this is what, for example, we are trying to do in OGC now, to communicate with other initiatives, because if every initiative will go with its own standard, there will be no standard. So I think that it is now necessary to speak together. Yes, we had already together with IMA some common meetings between OGC and RDA, and but there is a lot of work, because if we would like really to extend the possibility of usage, not only AI, but also any type of the analysis and modeling which are important, we need to go really at first to some way how easy access the data. Also with this, I saw a number of comments about metadata. As metadata again are a huge problem, and with the usage of AI, we will probably need to a little change the current models of metadata. And what will be very important, that every application, every solution will generate metadata automatically, yes, because we need, if we would like to reuse some result from other, we need to know what was the data at the beginning, how this was proceed, and what is the result. So we need to look a lot of on the metadata, and probably find some new way and new models for metadata.
Thank you, Karl. Over to you, Johannes. What is your take on this?
Typical mistake, I didn't press the unmute button. So in my opinion is that AI is, or the other way around, agricultural applications are very relevant for AI, but at the same time we are struggling with specific particular characteristics of agricultural applications. And one of them has to do with the lack of standardization, as Karel mentioned, but in my opinion, it has to do also with the fragmentation of the sector. So there are data are owned and collected by several different entities. So if you think of a farm, some of them are with the farmer, some of them are with the appliance manufacturers who collect data through isobus, etc. Others come from satellites, from public meteorological services, and all this needs to be from markets, price data, and so on. So all this needs to be integrated in order to start giving advices from a systems perspective. So while I see a lot of progress for pattern identification, so if we want to detect diseases on leaves, or for detecting specific kind of drivers, or give advices for specific processes, controlling greenhouses, all these kind of different applications related to agri-foods, robotics, into different, let's say, specific problems where we want to identify patterns, AI has been very successful. But when we are trying to look across the silos from a chain perspective or from a systems perspective in in a farm or even a region, then I think it's very difficult to employ AI at that scale, because both of the uncertainties, the number of processes involved, the conflicting, let's say, views and stakes of the competition between different processes and peers. So while I see AI thriving in agriculture for pattern recognition, when we go into systems understanding, I think there are more challenges that require also methodological advancements from AI to be able to create these holistic views of systems.
Thank you, Johannes. So we are slowly going towards the audit, but first I would like you to close on this topic a bit, Len. So over to you, and then maybe we can take some questions from the audience. Over to you, Len.
Yeah, I think it's well said. I have not much to add other than that agriculture and food production systems are incredibly complex. So I think every decision, if AI is meant for decision support, involves a lot of considerations, dimensions. I remember building models, and we all eventually always run into the curse of dimensionality, I think. So it makes quite difficult to scale up models and application areas. I think that's an area that we should work on, and that's because of complexity. It's also difficult to establish the business case, so the economics of applying AI in different processes is very often quite hard to establish. So I think other than the technical aspects, the social economic aspects perhaps should also be addressed to facilitate or accelerate the development. Thank you.
Thank you, Len. A quick check with Johannes. Shall we go to the audience now, or shall we take a last argument?
I think it's good time to involve the audience. We have a lot of people, so why don't we open the floor if there are any comments or ideas or questions? Yeah.
I noticed that Daniel Martini had a comment on data and code and data. Would you like to bring that comment to the floor, Daniel? Is that okay? I see you appearing. Please take the floor.
I can comment a little bit on it. I'm always a bit skeptical about these ideas, whether FAIR applies to data or whether it applies to code, because I have a real problem identifying the boundary between both, or the line you would draw, because in essence, simply programming language code is data. Otherwise, it would not be possible to process it, for example, in a compiler to produce some executable code. So where exactly shall we draw the line between data and code? And for example, if you look at what the semantic web is doing, I mean, the OWL language in its full variant is an undecidable language, so it has properties of a programming language. And if you declare a data set in OWL and semantic web technologies, you can as well see it as program code. So where is the difference? This is my problem I have with that notion. Yeah.
Daniel, I was asked by Kirsten and Emma to ask people who they work for. Would you want to share that with us? What is your context?
Yeah, I work at KTBL in Germany. We're an organization dealing with knowledge transfer in agriculture, and my area of expertise is actually applying semantic technologies in agriculture. I'm also part of the core team for the AgroWalk Thesaurus at FAO. So yeah, dealing lots with semantics in agriculture, actually.
Thank you. My thought on your comment is actually that maybe the specific problem that you're mentioning could be mostly in the sphere of semantic web technologies and semantic data, and maybe less in the classical machine learning context where you run a Python program which takes a lot of training data and then does predictions. But do you see other gray areas where the two overlap?
Yeah, I mean, with recent programming techniques, the difference is often a bit more well. It can often be easily seen. If you have a Python program, sure, you have some input and you have some program code which generates some output. So input and output are actually data, and the program sits in between. But if you look at programming languages which are for example, the so-called homo-iconic languages like Lisp or Scheme, where the data structure is basically the same as the code structure, then it's becoming really, really difficult to separate code from data. So it really depends on the language you're using, whether you can draw a clear line or whether not.
Yeah, sure, but with all and this kind of language, you need to interpret them to have a result, which could be a similar thing as querying a database. So yeah, I totally agree with you that the line there is blurry. Yeah, but when it boils down to AI models, I think it was a comment from Karel that's to me, it strikes a chord, is it enough just to share the model, or do you need to share also the data or the metadata about the data that you use for training, which in a way describe also the boundaries of what this model has been exposed to, the limitations during training and so on. And I think that's quite interesting, let's say, parallel to what you were saying, Daniel, as well, that it's not only about the artifact itself, but it's also about how it has been generated, and it could be a full proof of an old axiom that supports a statement, or it could be something which is like a black box deep learning model. But then if you know how it was produced, then maybe it's more transparent how it has been delivered. Yeah.
Before we hand over to someone else, if anybody wants to take the floor now, please do so. And otherwise, I have prepared my second victim. So if anybody has a question now, please take the floor. Otherwise, I would like to invite Jennifer Clark, because I kind of feel that you would have a question for Gideon. So maybe Jennifer Clark, thank you. You could maybe, if you could please tell who you are and where you work for, and maybe give your reflection and then hand it over to Gideon, if he, maybe with a question, if he's there. Over to you, Jennifer. Thank you.
Sure. So my name is Jennifer Clark. I'm a professor at the University of Nebraska in the United States. So hello from across the pond. I really enjoyed the conversation. And so I was responding to something that Gideon was talking about, where he was distinguishing between different types of AI. So AI that we use to provide general information back to like the farming community and the community at large, versus, you know, like AI where we get to very granular, very specific locations. So we want to apply AI to something very specific, or to individual people. And those are two different ways to use AI. And he was emphasizing that we need to be a little bit careful when we're talking about applying AI at the very granular level. It makes it super useful, right? Because everybody wants a personalized AI for themselves. But on the other hand, there's privacy concerns when you get down to the granular level. And as a statistician, I was commenting that we have, in the statistical field, we have a long history of trying to understand how granular can you go and still conserve privacy. Because in the US, we collect census data. And the census data we want to understand, we want to study, but we need to be careful about how granular we get because we don't want to be identifying individuals, right? And if you go down low enough, you can essentially, the population is small enough that you can identify people based on their responses. So there's a long history of understanding that. So I wanted Gideon to talk a little bit about that issue of the, AI for the community versus AI at the granular level.
Yeah, thank you very much, Jennifer, for that for that point. And that's exactly the kind of thing that I was referring to. And actually, I was. It's something that happened, and I put it in the post, but I'll repeat it. I'll repeat it here. A couple of years ago, there was a project which was it was a kind of a pilot. So looking at using mobile phone metadata in an African country to look at women's empowerment. So they had both the metadata from the cell phone company, as well as granular information that was collected in gender sensitive research that was really focused on women's empowerment. So you have the two data sets that normally are not together, and the idea was to see, if you have, can you identify issues around women's empowerment from looking at this mobile phone metadata, which people can get their hands on. It's not always easy, but it can be done, and people will go to some lengths to get that kind of information. I mean, I'm sure you remember a couple of years ago, the Washington Post showed the kind of information that you can look from. If you use the cell phone metadata, you can track people, and even though you don't know, it's just metadata, you don't know who they are, but if they go to the same house all the time, and you track that data, and you can say, okay, that person, this is his workplace. Oh, and now he's gone to the competitor for one afternoon. Oh, he's looking for a new job. I mean, that kind of information can get out. So the idea is there then, if you use this kind of metadata to in combination with other information, you train the model to predict things which are sensitive. Then you have something really dangerous that could be misused, even if it's used for very benign and very plausible reasons initially. That same algorithm can be abused. Take the situation that you have in for instance, Ukraine. It was a very peaceful country. If you had AI algorithms to help, whatever, and a country gets into war, and one of the warring factions uses that algorithm to be able to pinpoint certain people that they want to eliminate. Okay, then yeah, you're in really muddy waters as a data scientist who develop these kind of algorithms. So what I was pointing out, and this is what I discussed at length with the people who were working in that project on women's empowerment, is you need to focus your development on being able to identify things in the aggregate as accurately as possible, and ideally in a way that it is as imprecise and inaccurate at the very granular level, right? So that you have a tool which provides you the kind of information that you want to have in order to target communities, but you cannot use it to pinpoint to people. And that requires a different type of mindset in terms of how you develop your models and how you use the data, with this in the background, that you don't want to be able to re-identify. And so this goes a step beyond what you were saying earlier, which is, this is a general thing. You ensure that if you have statistical data, that you don't provide that at that level, that it points to individuals. Even if it is something that you do, you use granular data to generate model results, whether it's micro simulation models or AI. You do that in a way that you do not report at the level that that it points to individuals. I've used those types of micro simulation models which use census data, but you never report at the level that it looks at. It always looks at a sufficiently large group that it's still informative for policymakers or other types of decision makers, but it doesn't point to individuals.
Yeah. And I think that's one of the challenges in ag. So as Giannis and Lan were saying, you the knife analogy, right? You can't control the user, so you have to design a smart knife. So if it gets in the wrong hands, you can't be misused, which is challenging.
You don't use a stiletto in the kitchen. Huh?
Right. That's it. And then also, but in order for the model to be useful for, say, economics at the granular level. So what does the farmer want? The farmer says, I want more productivity, right? I want increased yield. And every farm is slightly different, right? And slightly different management practices, slightly different climate, slightly different management procedures, right? And so you have this, you're trying to make the model usable and helpful to those farmers, knowing that each farm is individual. And so you have to aggregate, but you don't want to aggregate too much, because then the farmer says, this is freaking useless. This can't help me, right?
Yeah.
And so it's interesting, that balance.
Yeah. So, and this is where you get this difference. So when you're doing something at the granular level, because you're informing an individual, and the individual is there, then you have to ensure that the data that is being used in the analysis is not out in the open. So you can say, okay, we have an algorithm. The algorithm is in open source. People can see, how it's done. If you use it, you need certain types of information, but that information is not publicly available. And so this is about the kind of data sovereignty. So making sure that then the farmer is the owner of the data, can use a publicly available open source algorithm in order to inform his own decision making. But it's not the data going out there in the open for everyone.
Okay. I would like.
Yes, over to you, and then over to you.
I would like a little react on the both things. First things, this discussion, I think, open for me other things which is important, and this is responsibility. Yes, because a few years ago on a conference about precision farming, there were a number of experts, and I asked this expert, are you ready to take responsibility if for your advice to the farmer. If the farmer will decide it in the wrong way, will you be able to pay his losses? But this is now much more open with AI, yes, because who will take responsibility for wrong decision? Yes, this is one question. Second, about this granularity, yes, I think that it is important problem, but also this is bringing different solution. Yes, on one side we can thinking about AI, which is on the end apply on the machinery computer, which is, for example, managing some fertilization. But of course, in agriculture, we can make the big models. So all require different data. So I think this is also for Jennifer contribution. But I think that I would like to discuss this question of the responsibility. I know that it is also discussed a lot of in automotive industry and others, because this is probably one from the biggest limitation. Who will pay for wrong decision?
Yeah, well, I will try to answer who will pay for the wrong decision. Depends on why you apply, you deploy AI for. If you deploy it for taking decisions, then you are responsible for delegating these decisions to an AI model. We have been doing that with all automated control systems, right? Either it is in wires or in other kinds. People who own and deploy this kind, you own a self-driving car, you're responsible for it. You're responsible for your greenhouse. Either you operate it yourself, or if you lease the operation to somebody else, then maybe this somebody else is responsible, but computers themselves cannot be liable for their decisions. It's those who decide to trust them. Yeah.
Johannes, we need to go to a quick closing round. So I would like to give a last quick word to Len, and then to Carl, and then to Johannes. Very quick. Len, last words.
Thank you. I think the issue of responsibility is very important, and I think probably much of it can be covered in a responsible innovation framework. And at the same time, and I think it's also important to make AI explainable so that people were aware of the potential consequences before they take on the AI algorithms or follow the instructions. Thank you very much.
Thank you so much. Thank you, Len. Over to you, Carl, for your last statement.
Yes, I think that this is important, and also I many times mentioned, yes, that and it was mentioned more time by Ioannis, that in some way we need not only artificial intelligence, but we need in some way explanation. Because, for example, if the solution will be used by farmers, then probably it's good to give him also some reasoning why is this decision, and probably the final decision has to be taken by farmer. Yes, because in other case, who prepares the model probably will need to take the responsibility. Yes, for
thank you, Carl. Over to you, Johannes. Short phrase.
Yeah, if I would try to summarize what I've learned today from the discussion, is that most probably FAIR principles are not enough. We need something more for sharing models and software related to AI in agriculture.
Thank you very much, Johannes. Thank you, everybody in the audience, and thank you for joining the Research Data Alliance within this community of practice of the improving global agricultural data. And we hope all to continue this discussion with you the next time. So please follow all the channels, and I wish you a very nice day and evening. Bye-bye.